All right, so the 5.1 is talking about a system of linear equations in two variable. So what is this? System of linear equations is nothing but the multiple linear equations are coupled. So we want to find out a solution set satisfying not only just one linear equation, but uh, all of the linear equations in the system. Okay, so right here, I told you linear system equation in two variable is an equation of the form ax plus by equals c. We haven't seen that, right? So in chapter 1. So that's the actual general form of linear equation, right? So, and then we know that the graph of the linear equation must be the what the linear straight line, right? So then we can think about yeah. So there are infinitely many ordered pairs that satisfy the single linear equations. Okay, we figured out that because the whenever x is given, whenever x give me a second. Yeah. Whenever x value is given, the y value will be determined, right? So for any choice of x, we can figure out y that makes this equation true, right? So there are infinite many solutions, and then visualizing that infinite many solutions, what? Then we're gonna get the straight line. So the line of the graph of the linear equation, which is straight line, represent what? The graph of the solution set. Okay. Anyway, so we are often interested in finding a single ordered pair that satisfy a pair of linear equations. Okay. So in 5.1, specifically in section 5.1, we are interested in finding single ordered pair that satisfy a pair of linear equations, or anyway, solution set in general. Solution set satisfying just two linear equations. Okay, so in section 5.2 is talking about the system linear equation containing the 3 or 4 linear equations. But section 5.1, we only talk. We're gonna study only the system of linear equations containing just two linear equations. Okay, so now, yeah, solving a system by graphing, let's see, any collection of two or more equations is called a system of equation, I told you. So solution set of system of two linear equations in two variables is the set of ordered pairs that satisfy both equations of this system. So this is the goal. We want to find our solution set of system of two linear equations satisfying both equations, okay? Keep in mind this. So here's the objective. So 5.1, a system of linear equations, right? Okay, with two variable, right? So first one, yeah. So first we wanna figure out the types of systems. Okay, I mean first one is supposed to be definition of system of linear equations. Okay, but we already studied, right? System of linear equation. Okay, and then second, yeah, we see types of system. Okay. So there are three types of system. We can classify the type of system by graphing. Okay. So I told you the linear equation with two variable, uh, the graph of linear equation two variable is straight line, right? So we just deal with two linear equations. It means that we deal with two straight line. Then we can think about three cases. Just two lines just cross. Okay. This is case one. In the case two, two lines is identical. Okay. And then third case, two lines is parallel. So now then here's what, so if in this first case, two lines just cross each other, it means that the intersection point, this is the only point satisfying both equations, because that intersection point lies what on the both line, right, straight line. It means that that point is the not only the solution of the one equation, but also the other equation. So in this case, the system has only one solution, right? Okay, and then we say that the system is consistent and independent. Okay, so whenever two lines are identical, it means that their equations are identical. Okay, so same slope with same the y-intercept. It means that then the system has infinite many solutions. So in that case, we say that system is consistent, dependent. Okay, and then third one, two lines are parallel, so it means that their slopes are different, same, but the y-intercept is different, distinct. Okay, so it means that since they don't meet right at a point, so there is no intersection point, so the system doesn't have solution, so no solution. So solution set must be empty set, right? So in this case, we say the system is inconsistent. Okay, so keep in mind this. So okay, consistent, independent, then consistent, dependent, and then inconsistent. Okay, so and then now okay, so third one is okay. So we figured out type of system, but eventually we need to figure out the solutions there, right? So how to solve the system, right? We need to figure out that. So there are two methods we're going to study. The first one is a substitution method. The second one is addition method. Okay. So yeah, so I'm going to go through this one today. Okay. So so back to give me a second. Now, so give me a second. Oh, sorry, I just forgot to the record. Okay, so once we figure out x equals 2, we need to figure out the y coordinate corresponding to x equals 2. Okay, so now then the y is equal to what? We need to figure out y coordinate corresponding to x equals 2. We're going to plug in 2 into what here? Okay. You can plug in x equals 2 into either equation, but I'm sure that it's easier to get y just by just plugging 2 into here. Okay, the y is going to be what 1 minus 2 times 2, which is negative 3, right? Okay, so you can see that point, the coordinate at this point is what? The coordinate at this point is 2 comma negative 3. Okay, so the system has a one solution. Okay, and then so that the system must be what? Consistent and independent. Okay, let's keep in mind this. So now, because I just forgot to record this problems, the solution to this problem. Let me explain the solution of this problem again. Okay, so you don't have to do this when you solve the system. Okay, but I just do this. I just figure out the graph of those two equations to let you better understand the problems. Okay. So and then we figured out that okay, so two linear equations meet the one point, cross each other. Okay, And then using the substitution method, I solve the problems. Okay. So now then, that's actually step 3. Okay. So find out the other variable. Okay. So now next one, let's see. So now next problems is this example 4b. So 2x minus 3y is equal to -2, and then 3x minus 2y is equal to 12. Okay. So let me solve this equation using addition method. Okay. Just give me a second. See. All right. So before doing that, yeah, let me figure out the graph of those two equations. Let me say this is equation 1, equation 2. I told you you don't have to plot the graph of the equations. Okay. So you just apply, when you get this problem, solve the system, you just apply the either substitution method or the addition method. Okay. So and then figure out the problem solution set so that we can figure out the type of systems. Okay. So the L1, let's say first equation, the graph of the first equation names L1. Okay. And then let's say L2 means the graph of the second equations. And then to figure out the graph of the equations, let me rewrite. Give me a second. So let me rewrite the both equation in what the slope intercept. So the first equation going to be y is equal to, okay, so subtract 2x and then divide by -2. Okay, so here we the subtract 2x and divide by -3. So we got -2/3x, okay, and then c plus 2/3, right? Okay. So now for the L2, y is equal to let's see, negative. So 3/2, what? 3/2, yes, 3/2x, right? And then minus 6. Okay. Now, what are you gonna do? Let's see, -2x. This should be positive, right? Not negative, sorry. So -2, 3, yeah, okay. All right, so x-axis right here, and then y-axis, okay. So for the L1, the y-intercept is 2/3, right? So maybe right there, 2/3. Okay, and then slope is 2/3 too. So not this 2/3 is less than 1. So the slope of the graph is not that steep. So maybe give me a second. Give me a second. Maybe like this, like that. Okay, so this is graph of L1. For L2 is, you see that -6? So y-intercept is -6, maybe right here, -6. Okay, and the 3/2 is the, well, look at the slope. 3/2 is greater than 1. So slope must be greater than the slope in L1. L1, right? This should be L1, sorry. Okay. So roughly the graph must be like this. Okay, so now what you're gonna do, yeah, you can see that two lines just cross so that they have one intersection point. So we can so that we can expect that the system has one solution in the solution set. So let's figure out that solution. Okay, so this is solution, the solution of the system. Okay, All right, so I'm going to use this addition method, okay, instead of substitution method, okay? So addition method is similar to the substitution method. So here, see addition method, okay? For the addition method, step one, um, we have to match the coefficient x or coefficient y, okay? So so for here, look at this. There's 2x and 3x, right? So I wanna to make them. I wanna just for example, yeah, the coefficient of x in the first equation to 3, so that the coefficient of this guy is same as coefficient of the x in the second equation. Okay, you can make the coefficient of y the same, okay, to be same, okay? So either one just fine, okay? So now you see to make the 2x to 3x in the first equation, we need to multiply 2x by what? 3 over 2, right? Okay. But see that here in equation, when you multiply something or divide by something in the equation, you have to do same thing in all other terms. Okay. Otherwise, that equal sign will be broken. So now 2x minus 3y is equal to negative 2, and then we multiply what? 3 over 2. Okay. So 2x times 3 over 2, and then negative 3y times 3 over 2, and then negative 2 times 3 over 2. Okay, I'm talking about first equation. Okay. All right. So keep in mind, step one is addition method. Step one is to match, okay, coefficient, okay, the pair of coefficients of x to be the same, or pairs of coefficients of y to be same. Okay, either one. So now then we got this 3x minus 9 over 2y is equal to, okay, and then negative 3. Okay, the first equation become this, and then we just write down second equation. Just copy the second equation, 3x, the beneath the this one. Okay, so 3x minus 2y is equal to 12. Okay, so now, right, what are you gonna do? Let me write down here. Okay, so 3x minus 9 over 2y is equal to negative 3, and then 3x minus 2y is equal to 12. So what are you gonna do? We're gonna subtract the second equation from the first equation. What that means, we just subtract the 3x from 3x and then negative 2y. We're going to do this 3x minus 3x, then negative 9 over 2y minus negative 2y, and then negative 3 minus 12. Okay. So now then we see that 3x minus 3x is gone. So that the one variable just gone. Okay. So actually that's cool. I told you the substitution methods, addition method, their goal is to reduce the system to one single equation with one variable. Okay, keep in mind this. So the reason that we did in step one, step two is this. In step one, the reason that we make the coefficient of x in the first equation to 3, which is same as the coefficient of x in second equation, because of we did that. Because the reason that we did this, because in step 2, when you subtract the second equation from the first equation, the x variable just gone. Okay, and then negative 9 over 2y minus negative 2y is going to be negative what? 5 over 2, right? Okay, and then that is equal to negative 3 minus negative 12. Negative 3 minus 12 is what? Negative 15. So y is equal to 6, right? Okay, y is equal to 6. Okay, so you may just lost or just giving the solutions here, because I just skipped a couple of the algebra processing, okay, process. So we got the negative 5 over 2, because negative 2 is nothing but negative 4 over 2. I just convert negative 2 to the fraction with a variable 2, denominator 2, so that we can subtract this one from that fraction easily. And then right here, so we just multiply negative 2 over 5 on both sides. So we're going to get to 6. Okay. So now what we're going to do, step 3, we just plug in 6 into either equation, first or second, to figure out the x coordinate corresponding to y coordinate 6. So I'm going to plug in 6 into the first equation. So you're going to get this. 2x minus 3 times 6 is equal to negative 2. So 2x is equal to 16, right? So x is equal to 8. Okay. So now you figured out that the coordinate at this point is what? 8, 6. So the system has only one solution. So the system must be consistent and independent. Okay. So now then, we'll see the problem system that is consistent, dependent, or inconsistent, right? So let's see example 3 in the textbook. So example 3, okay, A. So 3x minus y is equal 9, and then 2y minus 6x is equal 7. So, give me a second. Yeah. Now, let me use the substitution method. Okay, you may wonder that you may just wonder that which method, how can we figure out that which method is which method do we have to apply to solve the problem easily. So when you see the system, and then you see either x or y terms can be easily isolated. You see that here, negative y right there. So coefficient y is just simply 1. I know it should be negative 1, right? Negative 1. Anyways, either 1 or negative 1, it's easy to isolate y, right? For first equation. Then you gotta use substitution method. So in step 1, okay, so I'll just isolate y in the first equation. Then look at this. Y is equal to 3x minus 9. Okay. Now step 2, we plug in 3x minus 9 into the what? The y in the second equation. I mean y in the other equation. Okay. The another equation. So we got this 2 times 3x minus y minus 6x is equal to 7. Then we simplify and solve the equation for x. Okay. So we get this step 3. Okay, so we got 6x minus 18 minus 6x is equal to 7. So as you can see that, 6x minus 6x, 0, right? And then we got this negative 18 is equal to 7. But negative 18 equals 7 is not true for always. For any choice of x, for any choice of x, it turns out that negative 18 equals 7, which is not true. Right? So this system doesn't have a solution. Okay. So, because whenever you try to solve problems, it ends up with a false equation, negative 18 equals 7. Okay. So in this case, the system is what? Inconsistent. Okay, keep in mind this. Let's figure out what happened in the graph using the graph, or what happened in the system using the graph. Okay. So the L1, which is the graph of first equation. Okay. So y is equal to what? 3x minus 9, right? And for the L2, dy is equal to the 6x over 2, which is 3x, and then let's see, give me a second, 6x, and then plus 7 over 2. Okay. So now, you see here, these two guys have the same slope with different y-intercept. So that we can see that L1 must be like this, L2 must be like this. 1, L2. I think this is L2. Sorry, this must be L1. Okay, 2 lines are parallel. That's the symbol of parallel. 2 lines are parallel. You see that? That's why this system doesn't have solution, because those 2 lines doesn't cross. Okay. So see now, let's see the B. Okay. Okay, let me solve this one. Okay, and then I'll the lecture. Okay, so 1/2 x minus 2 over 3y is equal to -2, and then 4y is equal to 3x plus 12. So now I'm going to use substitution method. Okay, then so step 1, I'll just solve the second equation for y. Then y is equal to 3 over 4x and then plus 3, right? Now step 2, I'll just plug in 3 over 4x plus 3 into the y in the first equation. Okay, then we're going to get this 1/2 x minus 2 over 3, and then 3 over 4x, and then plus 3 is equal to -2. Okay, and now step 3, then we'll get this 1/2. We solve the equation for x. Okay, so x minus 1/2 x, and then minus 2 is equal to -2. Okay, so now you see that 1/2 x minus 1/2 is gone, right? Then we got this -2 is equal to -2. This is true, right? For any choice of x. Okay, now you see the difference between the problem A and problem B. Problem A, both problems, I use a substitution method, and then we end up with the numbers on both sides, right? But in A, the left number is different from the right number. I mean, number on the right hand side. It means that the equation end up with what? The equation end up with false equations. But the right hand, this problem B, we got this -2 equals -2. So on both sides, we got same number. So this is true for any choice of x. It means that this system has infinite main solution. Okay, that makes sense. Why? Because actually two equations are identical. Let me show you. So the first equation was this in the system. First equation was 1/2 x minus 2 over 3 y is equal to -2. And the second equation was this 4y is equal to 3x plus 12. Okay, so now what I'm going to do, let me see. So first one, give me a second. Okay, from here, both equations, I want to convert both equation to the slope intercept form. Okay, so give me a second. All right, so now here, for second equation, it's easy to isolate y to figure out the slope intercept form, right? So we just divide by 4. So we got this. For first equation, isolate -2 over 3y first, and then multiply by -2 over 2. Because we just multiply -3 over 2. Why -3 over 2? Because when you multiply -2 over 3 times -3 over 2, we're going to get 1 as coefficient of y, right? So the -1/2 times -3 over 2 is 3/4. And the -2 times -3 over 2 is 3. Okay. So you see that those two equations are identical. These two linear equations are identical. Okay. That's why the system has infinite main solution. So it means that the system is consistent. Okay. Consistent and dependent. Okay. Why this is called a dependent? Because there are infinite main solution. It means that one variable is the value of the one variable depends on the other variable, another variable. Okay, so all right, so let me stop here